Hi everyone, welcome to my channel and I'm Subhash Chandran and this is the stage 2 of our piping project. So this is going to give you an idea about how piping design projects are being executed in top class companies actually, and this is a beautiful example of how the execution and the design finalization generally happens. So in this video we are going to cover the pipe routing. So for those who haven't seen my previous videos, I would kindly request you to watch the part 1 video where I have covered the first step of the design and what we have to do in the first step, and what is our initiation of the design, how do we have to progress actually. So it will help you to understand this stage 2 as well. So in the previous videos we have completed the stage 1, which has covered the various topics of the location finalizations. So if you go and watch the video without skipping, you will be able to understand the sequence of the designs actually. So for now let's get started with the pipe routing. So without you wasting your time, let's move on. So today we are into the stage 2. In stage 2, what we are going to cover is the pipe routing, because we have finalized the location of an equipment, and the next step is that pipe routing. So in order to do the pipe routing, we have to do certain design activities and steps. So let's look into it actually. Before that, let's understand what is the recap of the design scope. This is basically what we have planned and how we are going to progress. See, the first in a design, you have to finalize the skid location. Especially I'm talking about this project, so because if you aware about the project titles and everything, and you'll be able to understand what I'm talking about. So please, that's why I'm again and again I'm repeatedly saying go and watch the part 1 video, so that will give you an idea about what I'm speaking actually. Okay, the skid locations has been finalized. Okay, now we have to do the pipe routing, and once pipe routings are done, then we will finalize the tie-in locations, and then we will move on to the pipe supports. So tie-in locations and the pipe supports I'll be able to cover in the next videos actually. Now I'm going to cover only about the pipe routing, because this is one of the extensive subjects, and so let's get started actually. So first, the stage 2, we are just starting now. So in stage 2, what are the design steps? Because when you're working as a design engineer, you must know what design you're doing. What is the intent of the design? What is your role? What is your responsibility? What kind of activity you have to do in order to finalize your design? So these are the important thing that should go in your mind basically. So basically here we have to do the conceptual design. Okay, though you're doing a simple pipe routing, but the design is a design. So design should have a progress. You have to start from A, then move to B, then move to C, then move to D. So it's basically a progressive development. So the progressive development comes from the conceptual design actually. So that's where conceptual design is must. So once after conceptual designs are done, we will design as per the P&ID, because P&ID defines the scheme, correct? So I will just highlight you what is P&ID. I mean the P&ID that we have used in this project. So basically you have to develop the pipe routing with respect to the P&ID, and your pipe routing has to be in line with the P&ID schemes. Okay, basically you're building something to enhance, to ease this process requirements, right? So now once P&ID, I mean design as per P&ID is done, then you will move on to the design optimization. Design optimization is where you actually finalize it actually. So in the previous 2 steps, you will you will arrange things in a random order in order to segregate your thoughts and process and the design actually. But design optimization is the stage where you will exactly say, this is what I want. This is the final requirement. So based on which you will be producing your drawings. Okay, let's move on actually. What is conceptual design? Okay, so all the topics that I'm speaking about here is specific to this project. Okay, because the conceptual design varies from project to project, the amount of magnitude of the designs and everything. But here we have taken a very simple pipe routing for your understanding, so that you will be able to apply your thought process in bigger projects also. Okay, so what is our P&ID? So this is our P&ID, correct? So what we had a vessel, and then we had a pump, and from the pump there is a discharge line that goes to another vessel, and here I have shown the separator output. Okay, so our scope is to put the injection skid. So injection skid is a skid which consists of the valve, and then the line from here it goes to the what do you call discharge of this line. So this is our entire scheme basically. So our scope is only to put this item. So the item which is which I have highlighted over here in black, and this skid is our new scope basically. So in our previous videos we have finalized the location of this blue skid. Okay, so now let's go to the plot plan. See, this is the plot plan that we had worked on in our previous videos, where we have finalized the skid locations, right? So if you look at the P&ID, so these are the three important equipments we are working around. Okay, so the one is the pump, from where the discharge goes to this equipment, which is the separator, right? So and the new equipment is the skid equipment. So skid we have placed over here. So this is the primary location you guys are working on. So your design will be around this area. So that's why I have marked over here. So now what next? The next is that you have to pull out the respective piping GAs. Piping GAs are nothing but piping arrangement drawings basically. So you have to take the respective piping GAs. So only then you will be able to finally develop the piping design. Now let's imagine the piping. This is the piping GA. Okay, so what am I showing over here? See, if you pull out the piping GAs, you will be able to understand the pipe routing. Okay, so this is just a sample simple graphical representation that I am showing actually, but if you really extract a piping GAs, that will have a lot of lines and everything. But for your clear understanding, I'm only working with respect to the equipments that we are discussing. So this is the pump we are discussing, and this is the equipment we are discussing. Okay, imagine this is the line, because if you look at the P&ID, the discharge of the P&ID goes to the separator, right? Imagine that this is the line as per the piping GA that goes to the separator. Okay, so how it goes actually, from here it comes, it goes all over the rack, and then it turns and connects with the separator. It's as simple as that, correct? So this is a the theoretical understanding, like a conceptual understanding. So you can say where is an elbows and flanges and all. Actually, let's not get into it. I'll come back to you one by one. Okay, so this is where it is actually. So now let me pick this over here. Okay, now imagine this is the conceptual line. Okay, what next actually? So now we have to put our piping from this kit to this line, right? So this is our scope. This is what the conceptual is about. So what is conceptual? So conceptual is about what you have to do, that you have to have a clear mind actually. Okay, you have located the equipment and you have located the existing line. This is the existing line. Okay, so in the existing line you have to connect a piping from here to here, because this is a new skid. From here to here you have to connect. This is your primary primary objective of the project. So this is what the conceptual. So conceptual you have finalized, because why I'm saying conceptual, imagine that this equipment is somewhere else on the other side of the rack. Then you have to identify where this line runs actually, which rack, whether it is in a different drawings or not, so how far it is actually. So those things you have to analyze. But since the equipment is placed over here, you can simply say that this line is traveling over here and this is where I have to come and connect, correct? See, one more information I wanted to give you is that this is the overall piping GA, but if you really go and extract the piping GAs, so all this equipment, for the entire area, there will not be one GA, there will be multiple GA, because the entire area will be divided into different sections of piping GAs. So you have to take it all the GAs. So now I'll just give you a theoretical understanding about, okay, when it comes to the actual reality, I'll tell you. Okay, now let's go to the design as per P&ID, because conceptual we have done. Now we are moving to the design as per P&ID. So as per P&ID, in this sense, you have to do exactly as per P&ID, because the P&ID represents your scheme, right? So what is that as per P&ID? You have to read the P&ID once again. See, the pump discharge from here, the line goes to the another separator, right? So what are the things over here actually? So you have a flange, you have a reducer, you have a PG pressure gauge, and you have a check valve, and you have an isolation valve. Then you have a connection from this to 2-inch line from the skid basically. So your interconnections of the new line with the existing line should be as per this. You should not connect this piping over here. okay, because this is the arrangement it is shown. You have to connect this line only after the valve. So that's your key intention actually. So where after the valve is not given. So this is an open point, so that we will discuss, okay, whether you have to connect as close to the valve or you have to connect it somewhere else in the what do you call, the extended line. So that we can still discuss actually, but the intention is that connect the line after the valve. So that is your intention, okay. Now let's move on. So now we are again back with the existing piping layout. Don't feel that other equipments are not visible. I just removed it because I don't want to confuse you, because we are the only area that we are working is over this equipment, this equipment, this equipment. So to get a better clarity, I just removed it, okay. So now what I'm going to do, I'm going to extract a piping GA of this particular area, because as I told you, the entire area will not have one piping GA, okay. Each piping areas are divided into multiple sections of drawings actually, and those sections will have a different drawing numbers. Then you have to go and verify which drawing it is. Generally you will have something known as a key piping GA, okay. So in the key piping GA you will be able to understand which are the sections and its respective piping GAs. So that will give you an idea about which exact drawing that you have to take it. Excuse me. So now we have to we are going to extract the piping GA for this particular area alone, because this is where we are working out. You can pull out the areas with respect to the north and east the coordinates as well, okay. Now let's go get in, okay. Imagine that this is the piping GA that we have extracted, okay. So I mean in reality, if you go and pull out the piping GA, you will get a particular area which with an exaggerated view of it, so that you will be able to understand many lines. So I'm just showing the equipments which are pertaining to our scope basically, but in real GS you will find a lot of connections like electrical cable trays and instrumentation cable trays. There will be other lines and everything, okay. I'm presenting over here for the better clarity, understand. So what is our primary equipment? This is the pump, and this is the skid, and this is the pipe rack, right? So what we have to do, that we will discuss now. Imagine once you extract the piping GA, the first thing what you will do, you will find the existing line. So this is the pump, okay. From the pump, what we have seen in the P&ID, we have seen that this discharge line goes to the separator, right? So which is the discharge line? This is the discharge line, because this is the line which comes from here top and it drops down over here. It has got a PG, it has got reducer will be over here, okay, and it has got the valves and check valves and everything, okay. I think there is some misrepresentation over here. Let me just correct it. So this valve and check valve needs to be reversed, right, okay. I understand, okay. Now let's get started. So okay, now you have found the existing line. So our only intention as per the scope is that we have to connect a line from here to here. So that is what our next step is, right? So just to give you an idea about it, once you place a skid, you have to define the location of the skid with respect to coordinates or with respect to the center of column. So here I have assumed nearly around 4.5 meter. You can go and check my previous videos of part 1 to identify why we have chosen this dimensions basically. So there were a particular line, from the particular line, and we have kept 1 meter. So altogether from center of the elevation equipment, you have kept some minimum dimension. Don't be so curious about this dimension. This dimension could be either 5 meter, 6 meter, but for why I'm keeping this dimension in the sense, just to ensure that this there is an enough access space for the operators to move around the skid and as well as the equipment. And if there is any piping or anything, I have maintained at least minimum of 1 meter. And over here also, so here in the previous video you can see that I have maintained nearly 1 meter from the foundations over here, but altogether it is 1.5 meter from the center of the line, okay. So now let's move on actually. So let's just go through the P&ID once again. So this is what we have to connect. Here I have shown one more thing over here, which is the supply point. See, this is an injection skid, right? So injection skid will have a supply and discharge also. Like what we have in pumps, we have the suction and we have a discharge. Likewise, you also have a suction and discharge to the injection skid. But injection skid, it's more of like an vendor supplied item, so you don't have to worry about the internal design. So you only have to concern about your nozzles. So one over here, this is the supply nozzle, this is the discharge nozzle, right? So our concern is the discharge nozzle, because we are not anything doing over here. So our major concern is over here, because this part is going to be supplied by the vendor. So this is the only part that you're going to work. So up to the flange, the vendor will provide, but from the valve to the entire piping, you have to do it. That is the role of piping design engineers. Now let's move on actually. So how we are going to do this design. So this is the existing piping, you have existing discharge piping, and in here you have to do this existing connection. So I think this connection, don't think about this, because I think in the previous slide I have corrected. So let's continue this discussion now as it, but in reality you have to have the check valve over here, and I think let's do it now itself, because otherwise it's going to confuse you altogether, so that I think we can have the perfect drawings, right? Understand? Okay, now let's start with it. Okay, so what I'm showing over here, you can see the nozzles. So this is what I was highlighting. See, when it comes to a vendor related items, the internal designs of the vendor will be taken care by the vendor. Okay, so you don't have to do it, but your external designs are your part, which is the piping. So here basically this nozzle orientation is important. So since you are interested only on the discharge nozzle, your discharge nozzle orientation is really important, but you also have a concern on the suction nozzle also. Because why? Because the suction nozzle is where you will have a supply from the trucks. Basically, injection skid will have some tanks, so in the tanks you have to supply the chemicals. So when you are designing the entire layout, you have to give this recommendation to the vendor. You have to remember this, understand? The vendor designs the entire skid, but the orientation of the nozzle you have to provide. So you have to provide the favorable and proposed nozzle orientations for the discharge and as well as the suction to the vendor. If vendor has any concern, he will come back to you. So if you don't have any concern, then you can follow, the vendor will follow your design. Generally there will be some sort of a concerns, and that concerns will have to be discussed with the vendor, and only then it will be finalized. But however, both vendor and yourself have to coordinate and finally arrange the nozzle orientation. So nozzle orientation is basically based on different factors. One of the factors here is suction. Suction in the sense you have to provide some supply. So basically you need to have a provision for the truck to come over here. Here we have an open space, so truck can come and put a hose connection and connect it. Okay, and this nozzle could either be over here also. The truck can be directly connected. So there are multiple options you can put it. But for the discharge, you have to have the discharge nozzle over here, so that you can take the piping over here. Okay, so let's move on. So nozzle orientations we have discussed actually. Now what else? Now in the discharge nozzle you are putting a valve, and then you are taking a line. Okay, so why I am routing the line like this? Because if you remember, in the P&ID our tie-in should be after the valve, correct? So I have placed the tie-in connection after the valve. So this is 2-inch and this is an 8-inch line. So from here what I'm doing, I'm taking the line straight and I'm just elevating here. Okay, this is an elevated line, and the line goes all the way over here and then drops down, and then it goes here and turns actually. So here there are many other informations you can observe. See, this floor elevation is plus 300 mm, which means that the floor height is 300 mm above the ground. Understand? The actual floor height. Floor height, FFL means finished floor height. Okay, and TO is the top of structure. This is what the term is, the top of structure. So it is 4800 mm. So what is the difference? It's nearly from FFL to the top of structure. You have 4500. Basically 4.5 meter height is there. Understand? So conceptually we have done, but now when you are routing as per P&ID, you have to match the scheme. The scheme is to put a value over here, run a line, and the line should connect after the val. Okay, this is the scheme. So we have finalized the pipe routing based on P&ID also. Okay, now the third step is very important. What is the third step? Design optimization. In design optimization, I'll tell you that you will get a different level of visibility. Okay, let's get started. So what we have seen, this is what we have done in the previous slide, right? So now let's, from here, what we have to think, that we have to analyze actually. Imagine that you have to put a line over here. This line has to be connected over here, right? So if you have to connect this line over here, how you will connect it? You have to cut this pipe and install a T over here. Only then you will be able to connect it, right? So this is a 2-inch line and this is a 8-inch line. You can refer the P&ID, okay, for the sizes. So 2-inch line has to be connected in the 8-inch line. So basically you need to have a 8 with a 2 reducer, okay, so that you can connect it. But how you will connect it? You have to connect it by cutting the line. So this is the cut point basically. So you have, your engineering should consider all the aspects actually. So you're going to connect it by cutting the line over here. So once you cut the line over here, you can install a T, and then you can bring back this piping again. You will be cutting over here. So you may ask that I have to cut at both the locations, right? From here and here to put the T. That's not required. You cut this over here and remove this entire piece, okay, and put the new piece with the new spool with the T, because you can prefabricate this much of item with the T, understand? So you can prefabricate and keep it ready. So once you get shut down, or once you are allowed to work, actually you simply cut, because making a 2 cuts will take time, right? But if you are ready with the spool, you just have to cut once and install your pipe spool with a T over here. So that job is done. Okay, so this is the one way that you have to approach actually, but there are other ways also. See, that's what I want to show. So design optimization is something that you have to think what else you can do it better, right? So that is what design optimization. Otherwise, what is the meaning of optimization? If you are going to optimize something, that should save some cost, that should save the life of the design, that should give some benefits to the customers, right? So now I'm going to take you to a different thought process. Okay, why do we have to connect it over here? Why not anywhere else? So what is the other option? Let me show you. We can connect it directly over here also, correct? Why do I have to connect it over here actually? Because see, anyway this line flow direction is over here, right? This flow direction is going to the vessel. So if you look at the P&ID, the line has been connected after the isolation valve, correct? So you don't have to worry about the distance, because our intention is to, if you go and read the scopes in the part 1, actually you will be able to understand the intention is to bring this chemical to the supply for this line, so that this flow will go to the separator. Okay, so it will save the corrosion process. So that's the intention basically actually. So it doesn't matter you connect here and you connect here or you connect here. So whichever is the easiest way that I can connect here. So what I'm feeling is that I'm feeling, instead of dropping the line here and taking a turn here and going here and connecting here, is more complicated than connecting directly over here. So my thought process is, so I can avoid some of the bends. I can avoid by taking by putting a lot of elbows. There will be pressure drops that I can avoid. I can directly connect the line over here. This is my proposal, but there will be some issues, right? You have to analyze those issues. What is that issues? Let's look into the view AA. View AA means that we are going to understand the arrangements in the elevation view. So this is the view that I'm going to see in the next slide. So for the view from here, okay, this is the view from here. Imagine that this is the line that that is coming from your skid, okay, and it goes and we are going to propose the connection with the 8-inch. See, this is the 8-inch line that comes from the pump. Okay, I'm proposing to connect directly, but is it really possible? Imagine, see, you have an elbow, okay, and you're going to connect the 2-inch line with the elbow. How is it possible? you cannot break the elbow at all, because the breaking the elbow is much more complicated process. So what is another way? So you have to find an other option. So here, just to give you an idea about it, see, these are shoe supports and these are shoe supports actually. So the conceptually I just placed a line over the shoe supports. So this we will discuss in the pipe support design, but now let's only look into the pipe routing. Okay, let's not deviate from the pipe routing. So our intention is to connect the line as simple as to directly connect to the existing line. So here, directly connecting to the existing line seems problematic. So what is another way? Let's go. Other way is that instead of directly bringing the line over here, you can move the line little bit. You can see how much I moved. So if you go back to my previous slide, actually see the line has been directly laid over here, but in the next slide I just moved it. Okay, you can see the gap. So I'm moving the line little bit over here. That distance you can keep it with respect to your pipe spacing calculations. So generally we need to have some nearly around 3 to 4 inch gap between the pipe to pipe, but this calculation needs to be done. Okay, I am not conceptually I'm saying actually. So here logically I'm just putting it actually, but in actual design we do a calculation, we check the enough space and only then we'll provide, because you need to provide support guides and everything. For that you need to have a space, but you have to understand the design first of all. So in order to make the routing, I'm just moving the line little bit. Okay, why I'm moving the line? So that I can bring the line outside and elevate it over here and then drop it and connect it to the 8 inch. Clear? I'll show you here actually. So I'm just taking the line in the straight way. I'm not connecting to the elbow. Parallelly I'm running it, and from here I'm just elevating and dropping it. So in the side view, so this is the view from here. Okay, in the side view the 2 inch line is elevated and dropped and connected with the flange connection. Okay, so now the only issue is that in the 8 inch header you have to install this flange connection. That can be done. There are multiple types of options are there, stub ins and stub out options are there. So even if you want, you can cut the line and put the T and those things are, or you can put the F weld outlet. So those options are available, but what I'm seeing is that this is the most easiest option. Okay, you can instead of dropping it down and going and connecting on the horizontal line, you can directly take it and elevate it and drop it. Okay, so this construction wise it is more easy. Okay, instead of making it more complicated, because anyway the flow is going to take the chemical to the separator. So you connect anywhere as long as the chemical goes to the separator, that's fine. Okay, now let's see what else we can do. See, like this is not the end of the story, so we are going to analyze in different other options also. Now let's see what are the other options available. Okay, see, what we have discussed is that you have extended the line and dropped it on the 8 inch so that you can provide with the connection with the stub in connection, right? Let me just go back. Okay, this connection. Okay, so what I said, this connection you have to make it actually. What if you have this connection already available in the header? So you can give a thought, right? So if I'm saying that if there is another best option, what is that best option? Is that I will find whether I will have any 2 inch spare connection available here. So if there is any 2 inch spare connection available here in the header, then I will not require to cut the line to install the wallet or to install the T or to do a stub in or nothing. I will simply remove the blind and I will connect my line over here. So this is the most easiest way. Am I right or wrong? Because see, what are all the options that we have seen? We have seen connecting the line over here, and then we have seen connecting the line over here. Now we are looking for an option. See, if you have to connect the 2 inch line, you need to have the 2 inch branch, correct? If the header already has a 2 inch branch, because there are cases where in piping design we used to keep some spare. Okay, so the spare is to make use during the future expansions or any sort of a future purpose basically. So you can use that purpose. So when I checked it, so I can say that I found a 2 inch connection. So I would happily choose this point for my connection. So instead of what do you call, putting the line over here, I will directly put a line over here. So I don't have to make an additional welding joints over here. I simply remove the existing blind and connect the line. So I just have directly extended. So only thing is that I just have to little bit extend, so that's okay. But anyway, I'm just avoiding the weldings and all. So complications I'm avoiding. So my line has become perfectly fine now. Okay, so this is how you have to think and develop your design. So as far as now the stage 2 is completed actually. So conceptually the pipe routing has been finalized actually. In the coming videos I will share how I'm going to finalize the pipe supports, and I will cover the tie-in locations also. So both I will cover in one video, because tie-in location finalization is not that complicated, it's pretty much easy actually. But support, you have to understand why you have to choose the right support, and what is the basis of choosing the right support, how to finalize this pipe supports, those things. But however, generally when you do a piping design, you have to give a multiple thought process. That is why we are analyzing all these options actually. All these options we are analyzing to ensure our design is perfectly fine. So I hope that this video has given you a very good idea about how the design optimization and the finalization of pipe routings are being done. Okay, so I will meet you with another fantastic video, which is going to be the final stage 3 video for this project, so that you will be able to use this knowledge in your interviews, because most of us do not know how to execute the piping projects and how piping projects actually works in real time. So this is the best example. So I will meet you in another fantastic video, and which is going to be the stage 3. So thank you so much for watching my videos, and thank you so much for supporting throughout this entire period of my YouTube career. So I will meet you again. Thank you so much.